So how do we actually know when we've built a truly intelligent general-purpose AI? Not one that's just a one-trick pony, but one that can learn and adapt to pretty much anything. Well, a recent paper from IBM Research has given us a fascinating new way to answer that very question. So let's dive in and break down what they found.
I mean, just imagine an AI assistant like Jarvis from Iron Man, right? You could ask it to book you a flight and then immediately switch gears and have it debug some code and then have it go browse the web to research some super complex topic. One single AI handling any task you can throw at it. That's the dream of a general-purpose AI agent. But how do you even test something like that? How can you fairly measure how smart it is?
Okay, so this definition right here is really key. We're talking about a system that doesn't need to be custom built for every single new challenge. It's designed from the ground up to be a generalist, a kind of jack of all trades that can figure things out on the fly. And that is a huge leap from the specialized AIs that we're mostly used to today.
But this brings us to a massive problem. See, testing these new generalist AIs with our old methods is kind of like asking an Olympic decathlete to compete against a specialized sprinter in just the 100-meter dash, and then immediately making them go up against a weightlifter. The tests themselves are totally biased towards the specialists. It's just not a fair race.
And this is what the old way looked like. For every single task, whether it's software engineering or customer service, researchers had to build a custom agent and a custom test for it. It was, frankly, a mess. Everything was siloed, which made it slow, incredibly expensive, and worst of all, you couldn't actually compare the performance of one agent to another.
I mean, think about it, right? Under the old system, it's a totally absurd question. There was no common ground, no universal standard. You just couldn't say if your web browsing bot was smarter or more capable than a code writing bot. You were just comparing apples and oranges.
And this is where the research gets really exciting. The team behind this paper decided to solve this problem by, well, essentially creating the first ever AI Olympics, a standardized, fair competition where any agent can compete on any task. So how'd they do it? With something they call the Unified Protocol. Now, you can just think of it as a universal translator. It breaks down any task into 3 simple parts. First, the task, a super clear description of the goal. Second, the context, any background info it might need, like a user manual. And third, the actions, basically the list of tools or commands the agent is allowed to use. Simple?
That 3-part protocol is the heart of a whole new framework called XGenetic. And if the protocol is the rulebook for the games, you can think of XGenetic as the entire stadium. It's the infrastructure that uses that universal translator to connect any agent to any test environment, creating a level playing field for the very first time.
All right, so the stadium is built, the rules are set, it was time for the main event. The researchers took 5 of the most prominent general agent designs and ran them through 6 different test environments, creating the first ever Open General Agent Leaderboard.
And here are the results. Wow. The top 3 spots were completely swept by agents using the exact same AI model, Claude Opus 4.5. The number 1 spot went to an agent architecture called OpenAI Solo, paired with that model. It achieved a really impressive 73% average success rate. But keep an eye on that column on the far right. That success came at a pretty steep price.
Okay, so let's zoom out a bit. What are the big headlines from this competition? Well, Claude Opus 4.5 was the clear MVP, no question. What's really interesting is that no configurations using GPT 5.2 even broke into the top 10. And maybe most important of all, these new general-purpose agents, they often perform just as well as, and sometimes even better, than the old specialist agents that were custom-built for these tasks. That is a huge validation for this whole approach.
But beyond the leaderboard rankings, this research uncovered a much deeper, more fundamental insight. It helped answer a key question about what actually makes an AI agent successful in the first place.
Think about it this way. What's more important? Is it the AI's brain, the underlying large language model like a Claude or a Gemini, or is it the AI's body, which is the agent's architecture, the specific code and logic that lets it interact with the world? What do you think?
Well, the answer is striking. When the researchers analyzed all the factors, they found that the choice of the language model, the brain, accounted for over 28% of the difference in performance. And the agent's architecture, its body, it explained a tiny 0.6% of the variance. I mean, it is not even close. The paper puts it pretty bluntly. The quality of the core model is the strongest factor by a mile, dominating the agent's specific design by more than 85 times. 85!
In short, having a smarter brain is just vastly more important than having a fancy body.
But, like we saw on the leaderboard, that top-tier brain power, well, it doesn't come cheap. And this leads us to the final, and very practical, finding from this research, a really stark trade-off between performance and cost.
This scatter plot just tells the story perfectly. As you move up the chart, performance gets better. As you move to the right, the cost per task goes up. You can see this clear trend. All the configurations that perform the best are clustered way up in that top right corner. They're amazing, but they're also the most expensive to run. Turns out, there's no free lunch.
Let's make this totally concrete. The top-performing agent running on Claude Opus 4.5 scored that great 0.73, but it cost a hefty $8.50 per task. Now compare that to the most cost-efficient agent. It used GPT 5.2 and cost just 17 cents, but its performance was way lower. The best performer was over 30 times more expensive. That is a massive trade-off for any developer or user to think about.
So, what's the big takeaway from all this? Well, this research really shifts our focus. It tells us that building the next wave of powerful AI agents isn't just about coming up with clever new architectures or cool designs. It's overwhelmingly about the raw power and intelligence of the core language model sitting at its heart.
And that leaves us with a big question for the future. As these incredibly capable AI agents become a part of our daily lives, you're going to face this choice yourself. Are you going to go for the absolute best, most capable AI assistant, even if it costs a premium? Or will you choose a good enough version that actually fits your budget? It's a trade-off that's going to define this next generation of technology.